multiplying and factoring is going to apply skills that you already know about, but just in ways that you haven't employed them before. We're multiplying using distributive property, and we're factoring like we've done before. We're just dealing with more letters and more exponents than what you are typically accustomed to. Our target is that we will multiply a monomial, which we know as the term, as the one word of the sentence, and trinomials, so 3 terms, using the distributive property, and then we're going to factor out the greatest common factor in a polynomial. So first let's start by multiplying a monomial and a trinomial. You see something outside the parentheses and you see things being added or subtracted inside the parentheses, your brain should think distributive property, which is accurately what should be happening. So I'm going to multiply 5n squared by each term on the inside. So by 3n to the third, by negative n squared, and by positive 8. So this first part of 5n squared times 3n to the third. 5 times 3 is 15. And we know for multiplying powers of the same base, you add their exponent, so that becomes n to the 5th. Let's go to the next one. 5n squared times negative n squared. 5 times negative 1 is negative 5. N squared times n squared is n to the 4th. And then 5n squared times positive 8. 5 times 8 is 40, so that'd be plus 40n squared. And that is it. If needed, you would combine like terms, but in this case, there are no like terms to be combined. But if for some reason there was, then your next step would be to combine those. Our next skill is that we can find the greatest common factor, that we can find the GCF of a polynomial. So looking at 3x to the 4th minus 9x squared minus 12x. The steps that I'm going to give you ideally are going to be happening in your brain. In the beginning, you may have to write all this out, but ideally, you're able to think through this more. You're really finding the greatest common factor of the numbers, and then also seeing how many of the variables that they have in common. So first, you're going to list the prime factors of each term. So you have 3x to the 4th can be broken up as 3 times x times x times x times x. 9x squared can be broken up as 3 times 3 because we're listing the prime factors times x because you have x squared. And 12x squared can be 2 times 2 times 3 times x. Your next step is you're going to identify the common factors. Let's get a highlighter. I have a 3 in common in each of those. And then I look to see the x's. I only have 1 x in common. Therefore, the greatest common factor is 3x. When you get to the stage where you don't have to necessarily list out the prime factors, you look at 3, 9, and 12, and you say, what is the biggest number that will go into all 3 of those, and that's 3. And then how many x's do they have in common? Well, since this one is only x to the first power, that's the maximum number that you could have in common. So our GCF is 3x. Let's take this a step further now, and let's factor out a monomial. Factoring is like the opposite of distributive property. You are undoing the distributive property. So to factor it out, you divide each term by the GCF. So let's look at this monomial. Look at the numbers, 9, 15, and 12. What is the greatest common factor of those? Well, 9 only has factors of 3 and 3. 15 has a 3, and 12 has a 3, but only one 3. So the GCF is going to be 3, and then let's see how many of the variables they have in common. This has 6, this one has 4, this one has 2, so they have x squared in common. So what I do now is I'm going to factor it out. I'm undoing the distributive property. So what is outside the parentheses is the GCF. So 3x squared goes outside the parentheses. Then inside the parentheses, I'm factoring out that GCF, which means I'm dividing it out. Since I'm undoing distributive, which is multiplying, I'm going to divide. 9x to the 6 divided by 3x squared would be 3x to the 4th. So in my head, the thought bubble that went on there is I took 9x to the 6 and I divided that by 3x squared. 9 divided by 3 is 3. X to the 6 divided by x squared is 4, because I know from last chapter I need to subtract the exponents. Now let's do that same thing for 15, x to the 4th. 15 divided by 3 is 5. X to the 4th divided by x squared is x squared. Now for our third term, 12x squared divided by 3x squared would simply be 4, because the x squareds would cancel out. So my simplified term there, let's bring that parenthesis in a little bit, would be 3x squared times 3x to the 4th plus 5x squared plus 4. This chapter, you're not really going to see the end game. You're not going to see the purpose behind factoring. Next chapter, when we're solving quadratic equations, this will be one of the methods of how you solve it. So you just want to trust me for this chapter that this is meaningful. It does have purpose. You're going to see that purpose next chapter. Now let's try this again. Factor the polynomial. We have 14 to the 3rd minus 35n squared plus 28. So I'm undoing the distributive property. I first need to find the GCF. So looking at those numbers, 14, 35, and 28. The greatest common factor is 7. And then looking at the variables, do they have any variables in common? No, they don't. So 7 is all that's going to be outside the parentheses. So let's factor out that 7 in each term. 14 to the 3rd divided by 7 would be 2n to the 3rd. My n terms are not decreased because I'm not factoring out an n. It's just 7 that's being factored in. I have a subtraction sign here because it's subtracting there. 35n squared divided by 7 would be 5n squared. And then 28 divided by 7 would be 4. So there is the factored form of that equation. Now let's go the other direction. Let's practice multiplying that monomial by a trinomial. This is what we started with. So we're going to multiply 10a times negative 6a squared, which will be negative 60a to the 3rd. That's because 10 times negative 6 is negative 60. A times a squared is a to the 3rd. Now let's go to the second term. 10a times 2a would be 20a squared. 10 times 2 is 20. A times a is a squared. So I've distributed to the first term, I've distributed to the second term. Now I need to distribute to the third term. 10a times negative 7 would be negative 70a. And that's it.